Hello everyone, this is Chemistry at Glance and my name is Aneta. If you haven't seen this channel yet, I'm working together with my blog where I share all the experiences about my A-level. I help with all the topics. And then after each topic, there is also a YouTube video with past paper questions related to this topic. So I've already done most of the topics for AS level. I'm now gonna start the A level course. So let's just get started. Today's topic is chemical equilibria, equilibrium constant, and acid-base equilibria. So all about equilibrium. Okay, so let's not waste any more time and just get straight into the questions. So ammonia is a very important industrial product. It's produced by the Haber process. It can be converted to the common fertilizer ammonium sulfate by reacting it with sulfuric acid. So the Haber process is nitrogen plus hydrogen. We form ammonia, and ammonium sulfate can be formed using sulfuric acid. So the first thing says write an equation for the acid-base reaction of ammonia with sulfuric acid. So what you want to start with is the ammonia. You react it with sulfuric acid, which is H2SO4, and what you get is ammonium sulfate. So if you're not sure how to write ammonium sulfate, we know the ammonium ion looks like this and the sulfate ion looks like this. These are the ions you should know off by heart for your exam, and then you just take the charge down. So we write NH4 with the charge of SO4, and then we write our SO4 and take the charge down through ammonia, but it's 1, so we don't have to write it. So our ammonium sulfate looks like this: NH4 bracket 2 SO4. The last thing you gotta do is just balance this equation, and we have 1 nitrogen here and 2 nitrogens on this side, so we're gonna write 2. And now we got 2 and a 2. So we have 8 hydrogens this side, 8 hydrogens this side, 1 sodium, 1 sulfate, 1 sulfate, 4 oxygens, 4 oxygens. The equation is completely balanced. So part II says, explain why ammonia behaves as a base in this reaction. So first of all, let's just say base is a H plus acceptor and acid is a H plus donor. So in this reaction, we have NH3 and it changes to NH4. That means it accepted a H plus. That means also that it's a base. Ammonia behaves as a base because it accepted a proton, which is our H plus. Okay, so part B says the Haber process can be represented by the following equation. This is our equation. For the equilibrium reaction, explain why a high pressure is used. So in order to know what pressure does to a reaction, you have to count the number of moles on the left hand side and the number of moles on the right hand side. So we have 4 moles on the left hand side altogether, and we have 2 moles on the right hand side altogether. So when the pressure is increased, the equilibrium moves to the side with the less amount of moles. So in this example, the equilibrium will move to right hand side when the pressure is increased. So increased pressure, equilibrium, just a short for equilibrium, is moved or shifted to right hand side. And this is because the number of moles on the right hand side is smaller than the number of moles on the left hand side. Part II says ammonia is removed from the equilibrium mixture as it forms. Whenever the ammonia is removed, the equilibrium will do as much as it can to restore that ammonium lost. So when we remove the ammonium, there's going to be more and more ammonium formed to restore the equilibrium. That's why ammonia is removed from the equilibrium mixture as it forms, because then we can make more and more ammonia. So in order to replace the ammonia, equilibrium will shift to the right hand side. That is a good thing because we're going to form even more ammonia. Part C says, how would the equilibrium yield be affected if the reaction were run without using the catalyst? So the equilibrium yield would not be affected at all. If we haven't used the catalyst. And the reason for this is because catalyst doesn't change the equilibrium yield or doesn't change the position of the equilibrium. It just means that the reaction is faster, so the reaction reaches equilibrium faster, but it doesn't actually change the equilibrium. Okay, so part D, predict and explain the effect of increasing the temperature of the surroundings on the value of the equilibrium constant Kc for the reaction. So I wrote here that the change in enthalpy is minus 92 kilojoules because that's what we get from the equation. And so it's minus 92. So the forward reaction is exothermic. And the backward reaction will be therefore endothermic. Endothermic, without an O. Okay, so when we increase the temperature of the surroundings, the equilibrium will do whatever it can to decrease that temperature. And it will decrease the temperature during an endothermic reaction, because in endothermic reaction, the heat is absorbed. So the endothermic reaction absorbs that heat. So our equilibrium will shift towards the endothermic side. So shift to the left hand side to reduce that heat that was increased. Because it will shift to the left hand side, and the Kc of any reaction is products over the reactants, we're going to have more reactants because we move to the left hand side, so we're going to have more reactants. And the bigger the number at the bottom, the smaller the number of Kc. So when we increase the temperature, the value of Kc will actually decrease. Okay, so I have another question for you. In the seawater, there are equilibria between carbon dioxide, hydrogen carbonate ions, and carbonate ions. And here are two equations. Now we have to use the Le Chatelier's principle to predict the effect on the first equilibrium and any change in the pH when more carbon dioxide is dissolved. So the Le Chatelier's principle means, says that whenever anything is changed, such as temperature, pressure, or concentration, the equilibrium will shift in order to minimize the effect of this change. So, looking at our first equilibrium reaction, when we increase the number of carbon dioxide, the equilibrium will shift to right hand side to use up that carbon dioxide. So adding more carbon dioxides shifts equilibrium to right hand side. Because it shifts it to right hand side, that means we have more H process present. When you have more H plus, that means the solution is more acidic, because H plus shows us how acidic a solution is. Because the more H plus an acid can donate, that means the stronger is the acid. So you have more H plus is present. That means it's more acidic. And when the solution is more acidic, the pH is lower. And that's all you need for this question. State what would be the effect on the concentration of carbonate ions if increasing the concentration of hydrogen ions in the second equilibrium. So, if we increase the concentration of these H plus ions, that means that the equation will move to the right hand side to the products to use up that H pluses. So the equilibrium moves to the right hand side to use up these H pluses. That means we form more of the products and we need less of the CO3 2 minus. So the answer to our question is, state what will be the effect on concentration of carbonate ions. The concentration of carbonate ions would decrease if we've increased the concentration of H pluses. So the concentration would decrease. In fizzy drinks, carbon dioxide is dissolved in water under pressure, and when that pressure is released, the fizz appears. In a bottle of fizzy drink, the following chemical equilibrium exists. So goes from gaseous to aqueous, or aqueous to gaseous. Chemical equilibria are often described as dynamic equilibria. Explain the term dynamic equilibria. So dynamic equilibria is a point where we actually don't see any change. So in a reversible reaction, where both forward and backward reactions happen at the same rate. So we don't actually see any change, but the change is happening. But it's happening at the same rate. So both the carbon dioxide changes from gaseous to aqueous at the same rate as it changes from aqueous to gaseous. When the top is removed from a bottle of fizzy drink, it goes flat because much of the dissolved carbon dioxide comes out of the solution. Explain why this happens in terms of chemical equilibria. So whenever we open a bottle of fizzy drinks, the concentration of CO2 gaseous decreases. That means that due to our chemical equilibrium and Le Chatelier's principle, the equilibrium will shift so that this change is minimized. So it will shift to left hand side to restore the CO2 gases. That means that we're going to have less CO2 aqueous. And that's what happens when we look at the equilibria. The carbon dioxide gases decreases, so the equilibrium moves to the left, so we have less carbon dioxide aqueous. Here is another question. Pollutant gases such as sulfur dioxide, SO2, produced from power stations can cause the acidification of lakes far from the source of the pollution. At a lake water pH of 6.0, water snails start to die, and when the pH reaches 5.5, fish also begin to die. So state how you would explain to the general public how the pH scale is used to describe levels of acidity. So how you would explain this is that the pH scale runs from 1 to 14. You would say that 1 is the most acidic, 14 is the alkali, and middle pH equals 7 is the neutral point. So the smaller the pH, the more acidic the solution is. Calculate the hydrogen ion concentration in the lake water when fish start to die. So as we said in the question, fish start to die when the pH is 5.5. And how do we calculate pH? We always calculate pH minus log of the H plus, but this time we want to calculate the H plus. So we do 10 to the minus of the pH. So 10 to the minus 5.5 gives us 3.2 times 10 to the minus 6 mole dm minus 3. That's our concentration. An equation for the reaction of sulfur dioxide with water is shown below. Here's the equation. Use the equation to explain that sulfur dioxide is described as an acidic oxide. So as we said before in this video, acidic means it donates H+. And now we have to explain why sulfur dioxide is thought to be acidic. Although sulfur dioxide doesn't have any H's in its compound, when it reacts with water, it forms H+. That means the sulfur dioxide, when it produces H+, so it's able to donate a H+. When SO2 reacts with water, it produces H+. And he's also able to donate that H+ to something else. That's why I said it's acidic. Now we have to use the Le Chatelier's principle to explain how the concentration of hydrogen ions H+ aqueous would change if more sulfur dioxide were dissolved in a solution that had reached dynamic equilibrium. So when we add more sulfur dioxide, we'll get more H+. This is because if we have more sulfur dioxide, the equilibrium will shift to the right to use up that sulfur dioxide. So the equilibrium shifts to right hand side to restore the equilibrium to use up SO2, the extra SO2 that we've put in. So we get more H+. Acids can be considered to be strong or weak and concentrated or dilute. For an aqueous solution of acid, explain the difference between the meaning of the terms weak acid and dilute acid. So, weak acid is the one that partially dissolves in aqueous solution. On the other hand, if we had a strong acid, that would fully dissociate in aqueous solution. And what that means is that if we have a strong acid like HCl, the equilibrium will be very, very, very far to the right. So we're going to have a lot of H+, because it will donate all of its H+ to the reaction. It's a very, very strong acid. If we have a weak acid, then we're going to have some H+, but we're also going to have some of the acid. Okay, and now we have to say what a dilute acid is. And a dilute acid is the one we have small amount of acid and large amount of water. Also, on the other hand, if we had a concentrated acid, then the place would change. We would have the large amount of acid and small amount of water. And here I have the last question. It's a long question, but it's the last question for this topic. Recently, hydrogen has been receiving interest as a source of energy. It can be prepared by the steam reforming of methane. Here is the reaction with our enthalpy change is a positive enthalpy change, so that's an endothermic reaction. And we are asked to write an expression for the equilibrium constant Kc given the units, if any. So we know our Kc is products over reactants. So we have our products, it's CO and H2. And if we have a coefficient at the beginning, we put it as a power in the equation. And in the reactants, we have CH4 and H2O. So that's the expression for equilibrium constant Kc. And now the units. So these are all concentrations. So we write mole dm minus 3. But we have 1, 2, 3, 4 of them here. So I'm just going to write 4 times over 2. So mole dm minus 3, mole dm minus 3. So these are the concentrations. The power 3, 4, and at the bottom is 2. So now we just want to cancel those out, and we're left with 2 of them at the top. So that's going to be mole 2 dm minus 6. We just combine these two. State the Le Chatelier's principle. So what I wrote is, if a system is subjected to a change, then the position of equilibrium will shift to minimize that change. That's the Le Chatelier's principle. That's an easy mark to get in the exam, by the way, so make sure to remember that definition. State, given the reasons, how the equilibrium yield of hydrogen is affected by I increasing the temperature at constant pressure. Here is our equation. We are looking at the hydrogen. What will happen to the hydrogen when we increase the temperature? So as we said before, it's an endothermic reaction in the right hand side direction. So it's going to be exothermic in the left hand side. If we increase the temperature, the equation will do anything it can to decrease the temperature. So to decrease the temperature, we can use the endothermic reaction, which absorbs heat. The endothermic reaction is in the right hand side, so we're actually going to form more hydrogens moving to right hand side. So the equilibrium yield of hydrogen increases as we increase the temperature. Now what would happen to the hydrogen yield if we increase the pressure? So whenever we increase the pressure, we need to find the number of moles, and we have 2 moles on the left hand side, 3, 4 moles on the right hand side. And increasing the pressure, the equilibrium moves to the side with less gas molecules. So less gas molecules will be on our left hand side, so the equilibrium shifts to the left hand side. Because it shifts to the left hand side, that means the hydrogen yield decreases as we increase the pressure. And now part B of this question, if carbon monoxide and hydrogen are passed over a catalyst at high temperature and pressure, methanol can be produced. Here's the equation. Again, we have the enthalpy change, and this time it's an exothermic reaction. State and explain how the equilibrium yield of methanol is affected by increasing the temperature. So here is our methanol. So this time exothermic reaction is in right hand side in the right direction, and our endothermic is going to be in the left hand side. If we increase the temperature, that means the equation again will want to use up this temperature, and it uses up when undergoing endothermic reaction. So because the heat is absorbed, endothermic reaction is going to the left. That means we're going to form less methanol. So the yield of methanol decreases as we increase the temperature. Next bit says when we increase the pressure. Again, we have to look at the moles. So we have 2 and 3 gas molecules on the left hand side. We only have 1 molecule on the right hand side. So when we increase the pressure, the equilibrium shifts to the side with less gas molecules. This is our methanol side. That means as the yield increases of methanol as we increase the pressure. And that's all. So that was all the questions for this video. Remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. I leave all the links in the description box below. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you. For now, I'll be very, very glad if you could like, subscribe, and share my channel and website with others. And see you soon. Bye.